main page. And first thing we need to do the calibration. So first for the calibration, I'm gonna open one of the files. Maybe here I'm going to 10.3 of one of my swells. So I'm going to open one of the plot that is 76, and I see the warnings where it has written no calibration has been done. So I'm gonna click OK, and in order to zoom in and zoom out in computer, you can always click like plus or minus sign. So I'm doing the minus so that I can see my tags. These are the PPAC 2022 10.3 is the tag that I want to analyze. So I'm going inside the calibration and there are different options. So I'm gonna use the pixel size method, and I have already selected object of known dimensions. So I'm clicking OK after that. So because I want to make a new calibration, I clicked on new calibration. I have calibration unit in centimeters. I'm clicking OK, and maybe I can take one more picture. And you see this green area is the command area, and this area we have a message, and it says horizontal calibration. Click the first end of the target. So I'm gonna click the first end of the target. For me, my known parameter or the known object is this tag. So I'm gonna click on the first end, and it is also asking me to click on the second end of the target. So I'm gonna click on the second end of the target, and it is asking me what is the target horizontal length, and target horizontal length is 12.7. So I'm gonna click that. Now in the command area in the purple, it is asking me to write the vertical calibration, and it is asking me click the first end of the target, and here this is my first end, this is my second end, and I know the dimension that is 1.5 centimeters. So I'm clicking OK. So we have done the calibration. Now we need to load this calibration because if you see at the top, there is nothing in the calibration file. So I'm gonna go add load calibration. Oh, or maybe first I will save this so that I can use this later. I'm gonna save this as a data calibration, and I'm going to keep it under like download data calibration 1. So I download, so I'm gonna go and load the calibration. And yeah, so this is my calibration that I recently did. So as you can see in the calibration tab at the top menu, just above this histogram, there is a data.calibration1 file. I have already opened that. My next step is to open the file, and open the file meaning where I want to save my data. So I'm going to open a new file, and I'm gonna write it as a 144. I think it was time point. Anyways, this is just a practice text file, and I'm gonna save it so that it will be saved in this file. And just to make sure you are saving in the correct file, you can see at the top of the top just above the information area, there is a data file, and because I clicked practice.txt, so I can see over here. Now I'm ready to process. There are so many options. It says image, just to save the image, or display, or there are so many other options. But since because I'm doing the manual or one by one, so I will zoom out because I want to make sure that I include all the regions of the roots that I want to analyze. So for this one, in the command area, there are so many options. First one is image edition mode. This one is just to like add the roots manually or do some additions. You know what, you can just like create the roots by yourself. Other one is like interactive nodule counting mode. What it does is like it helps to count the nodules, interact in an interactive mode. So, but first we need to do the analysis in order to do that. So I'm gonna go into this third option, which is the analysis mode. When I click that in the command area, it says click or make a selection to analyze the region of image. So I'm going to click the area where I want to make the where I want to analyze the image. So I'm making one rectangle area. You can give one sample identification because this is time point 3, and then this is plot number 76. So I'm just writing that. Swell volume is this one is just to use when we are using scanner attached to it, then it makes sense. But for our case, it doesn't make sense because we are not using the swell volume or something like that. So I'm just gonna write 0, or you can leave it as it is. So I'm gonna write the operator's name. My name is Suzu, so I'm just writing my name over here and I'm clicking OK. When I click OK, so it's going to analyze my image. And here you can see it has already done this. You can see it has separated these root diameters. I mean, like it has like different classes according to its thickness or the diameter of the roots. So the green ones are the ones representing the similar type of thickness that it is considering. And I'm gonna go over the command area, and there are 3 different options. The first one is original image selector, or we can see the analysis in the original image. But if we want to see the image in black and white or in the binary image, you just have to click on the second option, and you see we can see a very nice processed image of the roots. This seems really cool. Yeah, so in order to zoom in, you can just click on the sign plus, and zoom out, you can click on the sign minus. And in the global area, you see there is a region area that means how many you selected here. You have like width of the region, height of the region. There is a length of the roots, surface area, projected area, and average diameter, volume, and everything is in here. So yeah, so we can also get number of tips or forks or those information in here. In addition to it, if you want to count the nodules, there is an option in command area called interactive nodules counting. So I'm gonna click on there, and this here, if you zoom in, I think we cannot zoom in the command area, but you see number of nodules right now is 0. Now it is asking us to click the image to add nodules. So if we want to delete, we can click shift or shift and delete. But because I want to count the nodules, so I'm gonna go over here in the image, and I can see there is already 1 nodule. So I'm clicking over here with this red plus sign over here, and see in the nodule number of nodules, I see 1. So if I click on another nodules, it gives me another nodules, and my number of nodules is increased by 2 in the command area. Similarly, I'm going to click in all the nodules. 1, 2, 3, 4, 5. Yeah, looks like this plant doesn't have that many nodules. So yeah, you can like zoom in just to make sure that you are clicking at the nodules. kind of hard because all of the black and white. Sometimes it makes sense to um, like click on the nodules in the original image. In order to do that, all you need to do is like go in the first first picture, but still because we have used like light box and all, it's still hard to find out the nodules. That's how we count the nodules. This is the way of doing manual analysis. Now when it's done, I can go to image and click on save the original image with analysis. If I save this, and I need to mention where I want to save this, so I'm going to write like 76 plot number, and I'm saving this. So now it's saving. The next thing is about the batch process. For the batch processing, what I'm gonna do is like we do the everything like calibration, and the other methods are similar. All we need to do is like open a new file, or maybe since the file is already open, you don't need to open, you can save in the same thing. You can go inside the batch, click on analysis parameters, and I want to save pixels and analyzed both, and I click OK. And in the start analysis, I go to the folder where I want to do the analysis, but because I want to do in the download. Yeah, I want to go here and pp3. Okay, so what it does is like I have already selected the area, and now it is asking me which region should I analyze. If I clicked on whole image, it's going to analyze the whole image. But if I click on last image selection analyzed, then it will choose the region that I already selected. And if I click OK, it will start analyzing. And there will be several files. I'm not going to analyze right now, but I can show what we received. So if I go over here, phenotyping input. Yeah, so I will receive like this type of file. One with analyzed file, which will have like TIF written on it. Other one would be like pixel classified, and it would be like binary images like these ones. You can see these all are saved, but you won't be able to see the red black thing over there because it is visible when you open analyzed TIFF image. So for example, if I open, I'm gonna cancel all this. So if I open like root phenotyping, so these are my analyzed images. So if I open like these ones, it doesn't show me the analysis because this is just a pixel classified. And but if I want to see my analysis, so all I need to do is go inside the analyzed and click the pictures, and I would be able to see the analysis and everything in the region area. Yeah, so that's how the batch processing works. The thing too, there are some things that I needed to take care of when I was doing the batch processing because we click the pictures in different dimensions. So in order to avoid like occupying the areas that we don't want to analyze, we need to like separate the images into different folders. For example, here some of the pictures were horizontal and some of the pictures were vertical, so I separated them into two different folders, one for the horizontal, another one is the vertical, and I select the same area for for all the verticals, and I click the same area for all the horizontal image so that I don't include the reasons where I don't want to be, where I don't want to get the analysis of. So that's how we do the image processing. Thank you.